Hello, in this video I will be discussing integration by parts. So first we're going to derive the formula that we'll be using for this video. We'll start with the product rule of differentiation. The derivative of two functions multiplied by each other will be equal to the derivative of the first one times the second plus the first one times the derivative of the second. From here we can just integrate both sides. So when you integrate something that's being differentiated, you just get the original function plus a constant of differentiation, but in this case it doesn't really matter because, well, we can add it for now and I'll discuss why it doesn't matter later. And then due to the sum rule of integrals, we can split this up into the integral of this plus the integral of this instead of the integral of both, since they're equivalent. So that gives us this. And from here we can just rearrange for, doesn't really matter, I'm going to rearrange for this term, but these terms mean the same thing since f and g are arbitrary functions. So just one of them is being differentiated and another isn't. So it doesn't really matter for this proof, but I'll be isolating for this one. So I'll rewrite it here. Basically I'm going to be moving this over to the side, but I want to have this on the left side, so I'll write it here first. And it's going to be equal to this minus this. Okay, yeah. Well, we notice that, I mean, we have like this, right? But we notice that this is going to have its own constant of differentiation. And when you add two constants of differentiation, you still get a constant of differentiation. Like two numbers that can be any real number is just any real number. So this plus c is kind of unnecessary. So this is the formula that we'll be using. I'm going to simplify this by just letting u equal f of x and letting v equals g prime x, sorry, letting dv equal g prime x dx. This means that dv by dx is g prime x, which by definition means that v equals g of x. And if we have u equals f of x, that means that du by dv, or if we multiply both sides by dv, we just get this. Or actually, yeah, let's leave it as du by dv equals f prime x. Okay. Yeah. So using this and this and this, we can, and of course this, we can rewrite this in terms of uv, dv, and du. So f of x is u, g prime x dx is dv, and this is going to be equal to f of x g of x. So it's just going to be uv, right, f of x g of x, u times v, minus integral of f prime x, which is du by dv, times g of x, which is v dx, sorry, this is du by dx. And this is dx. Okay, that looks better. So this is the formula we will be using. And instead of duv, I'm just going to write vdu. And this formula is what we will be using to solve all of these questions. So basically, what you notice here is that we're going to be differentiating u and integrating v, right? So we want to choose, basically we can make any thing in our original integral u and dv. We want to choose to make dv something that we want to integrate and u something that we want to differentiate in order to simplify the integral. So let's start with this example. We have the integral of, so we can just use the constant rule to just take out the 3 over 2. This works in differentiation and integration because constants don't affect, they both don't affect the area under the curve, like besides just scaling it, and also differentiating, it doesn't, it's sorry, whenever you have a function, like if you're differentiating a constant times a function, when you differentiate it, it's just going to be the constant times the derivative. So therefore it makes sense if you're integrating. If you're given some constant function times another function that you're trying to integrate, you can just leave this function out and integrate this function to get this, right? So that's why we can take out the 3 over 2, and we're just left with e to the minus x times x dx. So I think e to the minus x is probably something that's a little bit easier to integrate than like later, right? Because differentiating this or integrating this doesn't really change much about it, because when you differentiate e to the minus x, you're just gonna be getting, you're using chain rule, it'll just be e to the minus x times minus 1, right? You're not gonna be changing much about it. So but if we differentiate x, we can get rid of the x, it'll just go to 1. So that's why we want to make our u equal to x and our dv equal to e to the minus x dx. So from here we can see that if the original function, well basically we want to integrate e to the minus x to find our v. And to do that, we can see that if we have minus e to the minus x, if we were to integrate this, or differentiate this, then due to the chain rule, the minus would come out and cancel it, and we'd be left with e to the minus x. So yeah, e to the minus x actually has the same derivative and integral, so that's pretty cool. Yeah. So this will be our v, and our du will just be dx since u equals x. Yeah, so now we have, I think, everything we need. We know that we have 3 over 2 times, okay, so using our formula from here, we just have u times v, which is minus x e to the minus x, minus the integral of v du. So minus e to the minus x dx. And now this is very easy. First we can take the minus and just make this plus, and secondly we already established that this integral is just going to be minus e to the minus x plus c, obviously. kind of sums it up. We can put the minus here, make these pluses, and this looks pretty good. So let's put this into here and see if we are correct. Plus minus x plus c. Perfect. Okay, so that was a beginner question. I'm gonna do one beginner, one intermediate, and one advanced question. So let's do an intermediate question. For the same reason as before, we can take out the 5/7. So we just have x cubed cos 3x dx. Now this is obviously very easy because we can clearly see that if we just apply this strategy 3 times, we can, each time cosine will just alternate between cos and sine, and 3's or 1/3's because its integration will keep coming out of it, but we're going to keep differentiating x, so that's where our powers are going to be reduced eventually to 0, and we're just going to have an integral of cos or sine, and that's going to be very easy to do. So this is pretty tedious. There are methods you could develop to try and do this quicker, but I'm going to go through it the longer way, so just the more rigorous way to show all our work properly. So the first thing we're going to do is make this our u and this our dv. I'm going to try and go through this as quickly as possible. We know that du equals 3x squared dx. Just using power rule, bringing the 3 down, decreasing the power by 1. And that dv, well, if dv by dx equals cos 3x, then that must mean that our original function v was just sine 3x divided by 3, because the derivative of sine is cosine, and due to chain rule, the 3 would come out and cancel with this over 3. So therefore, our first iteration of this is going to be uv minus the integral of v du. So that's going to be, this is v from here, and du is just, oh, the 3's cancel each other out. That's pretty cool. Okay, now we have to go on to our second iteration of this. So I'm just gonna ignore this for a second and just focus on this part. So this part right here, sine 3x x squared dx. Okay, so again, same idea. These are going to be our dv, right? So again, we have du by dv, just going to be 2x. Not by dv, du by dx equals 2x. So sorry, just du equals 2x dx. Just like before, we had du equals 3x squared dx. Now we have 2x dx. Now it's still going to be divided by 3, but it's going to be minus because derivative of cosine is minus sine. So in order to have positive sign, we must have initially had a minus cosine, so the minuses could cancel out. So that means that our v is just going to be equal to minus cos 3x by 3, right? Since our dv by dx was just sine 3x. right? So when you're going from sine to cos, you have to add a minus in integration. When you're going from cos to sine, you don't need a minus. So it's kind of like the opposite of it's kind of like the opposite of, or sorry, yeah, it's the opposite, because we're going from sine to cosine, we have to add a negative. So that's opposite from differentiation, where when you go to the derivative of sine is positive cosine. The integral of sine is negative cosine. So it's going to be the opposite of the differentiation, which makes sense because we're basically undoing differentiation with integration, right? So yeah, we have our v, we have our du. That's pretty perfect. Yeah, we can now do our use our integration by parts to rewrite this as uv minus the integral from the integral of v du. So I guess I'll take the 2/3 out, right? We're multiplying these together, and then we just have, and we can also take the negative out, right? So we just have cos 3x x cos 3x dx. Because we multiply these together, you get minus 2/3 x cos 3x dx. The minus 2/3 we can take out, and there was already a minus here, so it turns positive, and yeah. So that's good. But now we have to do this, so this is our last step. I'll try and go as fast as I can. This is our u, this is our dv. Du equals dx. V equals sine 3x by 3. Right. Yeah. Now we can start doing it. So uv is just going to be x sine 3x by 3 minus integral of v du. Let's take the 1 over 3 out. And now finally we have something here that we can solve. It's just, again, we already did this already. Just this, right? Plus e. Don't forget the plus e. So these are going to cancel. It's going to be over 9. Okay. So this whole thing here is going to be x sine 3x by 3 plus cos 3x by 9. Alright. And remember, this is kind of crazy, but so this is all going to be minus, so we're just going to flip everything to make it plus. So we have x squared cos 3x by 3 plus, well, I don't know about plus. No, sorry. Rather minus, oh, but there's a 2/3 here. So let's do that. 9 and 27. Okay. And they're both going to be minus, I guess. Hope. There's a good chance we went wrong, but hopefully everything is good. So these are both going to be minus. I'm just going to move them. Ooh, that this is just going to be minus and minus. Okay. And 5/7. Alright. There's a c. Well, I'll just add the c at the end. Okay. So hopefully this is right. It's kind of a lot, but hopefully it's right. Have x cubed sine 3x. Okay. By 3 plus x squared cos 3x by 3. Okay. Alright. Minus plus c. Yeah, I'm not feeling too confident about this, but we'll see what happens. This does not feel like it is going to work, but we'll see. Okay. I don't know. This feels like a little sketchy. Yeah, that makes sense. Maybe I'll put this in brackets too. Yeah, something's wrong. Okay. I'll try and rewrite everything, and if it doesn't work, then I don't know. Hopefully it'll work. So, okay. We have something plus something. Okay, something plus something minus something minus something. Here it's x cubed sine 3x by 3. Here it's x squared cos 3x by 3. Here is 2x sine 3x by 9. And here is 2 cos 3x by 27. That's it. It's closed for me, right? Okay, correct. I'm not gonna lie, that I kind of expected us to make a mistake there somewhere, but we didn't. So, okay, this is gonna be our last problem, and yeah, I'm kind of amazed that worked. So, okay. Again, we're gonna take the 9/8 out. We just have t squared ln. So we can use the rules, logarithmic rules, to bring the 2 over to the front, and then use the rules of differentiation and integration to take it out here. So, well, I guess this just becomes a 4, right? Yeah, ln t. Hopefully it's not ln of t squared. Hopefully it's ln of t squared, but that it looks to me like that's what this means. Yeah. Looks good. Okay. So whenever you have a ln t, we probably want to differentiate it so that we can get just like 1 over t, and then we just have powers of t. So in order to do that, we obviously have to make our ln t our u and t squared dt our dv. So obviously our v is just going to be t cubed by 3. We're just finding the antiderivative or the integral of t squared. We know our this is our u, so du is just 1 over t dt. And yeah, so using this we can rewrite this integral as uv, so t cubed ln t by 3, and then subtract the integral of v du, so that's just going to be t cubed by 3 times du, like this. I don't know why this is advanced. This looks really easy to me. You just take the 1 over 3 out, make this squared, and we're basically finished. Yeah, I'm a little bit confused why this is I'm kind of confused why this is advanced, but whatever. This is just 3 over 4. Yeah. T cubed ln t minus t cubed by 3. You just increase the exponent by 1 and divide by the new exponent. Yeah, and just plus c from this, right? I don't. Okay. I guess this is right. I mean, this doesn't seem so advanced to me, but that last one felt much harder. T cubed by 3. Okay. That's it, right? Ooh. We made a mistake. Alright, let's find the mistake. So we had this as our original thing, right? Which looked to be pretty good. They're telling us here to make our u ln t squared, and that our df is just going to be 2 ln t by t. Huh. Oh, never mind. We didn't make a mistake. It's just I didn't understand what they meant. They meant it like this. Right? So then if you differentiate this, you get 2 ln t. 2 ln t times 1 over t. So yeah, exactly. Yeah, so they meant this, and I thought that they meant this. So it's not really a mistake. It's just a misunderstanding. We can see if the way that I interpreted it was correct, and then we'll redo it with this interpretation as well, just to show both of them. So okay. So the way I interpreted it was like this. So 9 over 4 t squared ln t. Let's just write it like this. Ln t squared, and then make this an 8. Okay. So mm, hmm. Um, Interesting. So they also had 9 over 4 of this. And from here, I think our step should have been right. Let's see. Oh, you know what? They never took the squared out. I think if we do it for them, then it should be 6 log t minus 2, because that's just a rule of logarithms. And then from there, you'd have 6 over 8 is 2/3. What? Sorry, 6 over 8 is 3 over 4. Never mind. Yeah. So yeah, then you'd have 3 over 4 t cubed log t, which is what we have, and then also minus 2 over 8 is 1 over 4, so t cubed over 4, which is perfect. So we got it right. Like, it's okay. Log of t squared is definitely the same thing as 2 log t, right? That rule makes sense. Like, yeah, I don't know. Like, for example, if you have log of e squared, it should just be 2, because ln of e is 1, right? So if I did ln of e squared, it should just be 2, right? Yeah. I mean, so I guess what we did is fine. Let's redo it with their interpretation now, where they wanted us to do 9 over 8 t squared ln of t squared, like this. And we'll use their suggestion here. We're going to make our u equal to our ln of t squared, and we're going to make our dv equal to t squared dt, and we will just take the 9 over 8 out of the integral. Okay. So from here we have du equals 2 times ln t to the power of 1 times the derivative of this, which is 1 over t dt, and our v is just going to be t cubed by 3. So from here we have that this is equal to 9 over 8 times uv So ln t squared times v. Nope, not like that. Like this. Ln t squared times 2 cubed by 3 minus integral of v du, which is just going to be, these t's cancel out to t squared. No, let's do that later. Just t cubed over 3 times this, which is 2 ln t over t. So we can take the 2/3 out, make this a t squared, and I guess that we should use here, we should use again the integration by parts method to change ln t to just 1 over t. So this is pretty like repetitive. It gets pretty boring, but it's good practice. So yeah, we have our u equal to ln t and dv equal to let's just write our v. Our dv is dt, or t is t squared dt, so our v is just going to be t cubed by 3, which is what it was last time. We still have t squared, so yeah. So from here we can rewrite this integral as uv, oh, I didn't write du equals 1 over t. So uv t cubed ln t by 3 minus the integral of v du, t cubed by 3, 1 over t dt. And yeah, now this is solvable. This is just take out the third. It's just t cubed by 3 or by 9 if we combine it with this. Yeah, let's try and put everything together. So we have 2/3, that's just going to be 2/9 t cubed ln t. So, well, it's minus, right? Yeah. Oh, so now minus minus will be plus. Plus t cubed by 27. Okay. No 2 here. There is 2 here, sorry. Yeah, the 2/3 expands over this here, so yep. 2/3 applies here. It also applies to this. So you get the minus 2/3 times this will be minus 2t cubed by 27. Well, plus, because this is minus as well. So minus minus will be plus. Yeah. And oh, that's the answer. Okay. Cool. We applied the minus to these terms. This integral resulted in only 2 terms. I guess, yeah. Okay. Hopefully this is correct. Okay, ln t squared t. Okay, let's, instead of this, we have something We only have 3 terms. Okay. Minus something plus something. Something minus something plus something. Okay. The first thing is this. It's something squared times, we don't need times t cubed, divide by 3, and here we just have ln t. Okay, that's done. Here we have minus 2 over 9 okay, before it was just, okay, so just 2 t cubed ln t by 9. It's here, it's just 2 t cubed by 27. That's it.